Thank you for joining us. We are still on with our revisions. A mock chemistry examinations. We are looking at question number 3, a question on gas laws. The question we have reads, give the name of Roman 1, a gas whose volume is theoretically 0 at -273 degrees Celsius. This gas is known as an ideal gas. Roman 2, the name of the temperature at which the volume of a gas is assumed to be 0. This temperature is known as absolute zero temperature. Absolute zero temperature. B. In an experiment, ammonium chloride was heated in a test tube. A moist red litmus paper placed at the mouth of the test tube first changed blue and then red. Explain these observations. 1. Ammonium chloride heated dissociates into ammonia and also hydrogen chloride gas. Ammonia is basic, then hydrogen chloride gas is acidic. But looking at the densities of ammonia and hydrogen chloride, ammonia is less dense and therefore moves faster. So we can say ammonium chloride dissociates into ammonia gas and hydrogen chloride gas. That is the first point. The second point, we can say basic ammonia reaches first the red litmus paper and turns it to blue, and then acidic hydrogen chloride gas turns blue litmus paper red, because it actually reaches the red litmus paper later. We move to part C. Part C reads, Figure 3 shows an experiment that was used to verify a certain law, X. This is not the actual name of the law in the laboratory. Use it to answer the questions that follow. We have the colored water column here. We have the air representing a quantity known as volume in this case because of the space occupied by air. We have warm water here, which also signifies something to do with temperature. So at this point, the law that talks about volume and temperature is known as Charles' law. So when we move down, we are supposed to identify law X verified in the setup above. So this is what we call Charles' law. Then we are required to state law X, which is Charles' law. And Charles' law states that the volume of a given mass of a gas is directly proportional to its absolute temperature. to its absolute temperature at constant pressure. So provided the pressure is kept constant, the mass of a given mass of a gas is directly proportional to its absolute temperature according to Charles. We move down to Roman 3. Give the observations made in the experiment in this figure. Remember, we have the colored water column. So once the flask is heated, it expands and therefore creating more space, making the colored water column to drop. And after some time, when the air gets heated up, the air expands and therefore occupying more space, pushing the colored water column upwards. So we can now answer the question and say, first, the colored water column, drops and rises after some time. Why? We can now explain our observation in B Roman 3 above. We can say when the flask is heated, it expands due to the heat from the warm water. And when the air gets heated, it expands, occupying more space, hence pushing the colored water column up. Then D, we are supposed to give two applications of gas laws. Gas laws can be applied in very many areas, including in vehicle tires. We also have an application on hot air balloons. We also have an application in what we call fire extinguishers. We have also an application in what we call air conditioning, and refrigeration. We also have applications on areas of what we call weather prediction. So thank you for watching and welcome to our discussions. And in case you're watching this channel for the first time, please take a second or two. You click the subscribe button so that anytime we produce a video like this, you will automatically be given a notification.